Let's deepen and expand our understanding of the volume of right rectangular prisms while talking about unit cubes together. Throughout this video, we have 5 different practice problems where we're going to be looking at volume, but also looking at these tiny little unit cubes that we're going to fill these volumes up with. For number 1, we have this right rectangular prism, as you can see, and there are going to be a bunch of these tiny little identical cubes filling it up. We're going to have 16 little cubes going this way, 9 little cubes going this way, and then 23 cubes stacked on top of each other all the way up to the top here. So the length of each of these cubes is going to be 1/4 inch. We see that right over here. The question is what's the volume of this entire prism going to be? So again, keep in mind that we are taking a bunch of these tiny little cubes, right? Each of these cubes look something like this. And if it's a cube, all their dimensions are going to be the same. So we know the length and the width and the height are all going to be 1/4 or 1/4. So if we consider this side to be the length, this one to be the width, and this one to be the height, well, let's go ahead and take a look at this. Well, the length here, we know that it's going to be 16 of these little cubes. 16 times what? Well, they're each 1/4, so 16 times 1/4, that's going to be 16 times 1/4 is just 16 quarters, right? So we could have a total length here of 4 inches. That's what that dimension is going to be across the length. What about the width? Well, the width, we know that we can fit 9 of these things. So 9 times, each of them are 1/4. So 9 times 1/4, that would just be 9/4. And so what's the dimension going to be for the width there? Well, it's going to be 2 1/4 inches. That's how wide this prism is going to be. And how tall is this thing? Well, it's going to be 23 of these cubes stacked on top of each other. So the height here, we're fitting 23 of these cubes. Each one of them is 1/4 each. So let's see, 23 times 1/4 is just going to be 23/4 or 23 quarters. As a mixed number, this goes in 5 times with 3 left over. So it's 5 3/4, and this is inches. Okay, so this is going to be the length, the width, and the height here. We can go ahead and take each of these dimensions and find the volume. All right, so for volume, it's going to be the area of the base multiplied by the height. In this particular case here, we know the base is going to be a length times a width, as all rectangular prisms are. A rectangle on the bottom, so we have this length times width times height. So let's go ahead and substitute in the length. I'm going to go ahead and use the improper fraction version. So the length is 4 or 4/1. That's this right over here. The width is 9 over 4. That's the same thing as 2 1/4. So I'm just going to write as 9/4 right away. And then the height here is just going to be 23/4. So I'm going to write it as 23/4 right away. Just to simplify a little bit earlier, I'm going to go ahead and take these 4's, cross them out. So instead of multiplying by 4 and divide by 4, we can just go ahead and cancel those out. In the numerator here, we still have a 9 and a 23. So if we go ahead and take 9 and multiply that by 23, that's going to be 207. And then in the denominator, we just have 1 times 1 times 4, which is just going to be 4. And if we go ahead and do some long division, we can do 207 divided by 4, and that's going to be 51 with 3 left over. So it's going to be 51 3/4 here. Okay, so the volume of this prism is going to be 51 3/4 inches cubed. This would be the volume. All right, let's check out another problem. For number 2, we see we have a right rectangular prism. It's made up of 8 of these small cubes, as you can see below. Each cube has an edge length of 1/5. It says, what's the volume of this prism here, right? So I'm just going to draw one of these little unit cubes on the side, just so we can practice seeing it on its own. So we have this little cube here, and each one of these has a dimension of 1/5 by 1/5 by 1/5. Okay, so that's what was going on over here. So let's see, if we have 1/5, 1/5, 1/5, 1/5, then hopefully we can see here that the length here is going to be 4/5. Right, if we go ahead and just see all of them going across, that's going to be 4/5 of an inch. What about going for the width here? Well, there's 2 of these cubes going backwards here. So the width here, if we have 1/5 and 1/5, that's going to be 2/5. That's how many inches or inch wide it's going to be. And for how tall this is going to be, well, there's only 1, so the height here is just going to be 1/5 of an inch. Okay, so we have all the dimensions that we need here. So let's go ahead and just say the volume is going to be the area of the bottom multiplied by the height. We know the bottom is a rectangle, so we can say length times width. And so the length is 4/5, the width is 2/5, and the height here is 1/5. Okay, so if we go ahead and just multiply the numerators together, 4 times 2 times 1 is just going to be 8. And then in the denominator, 5 times 5 is 25. 25 times 5 is going to be 125. So the volume here is going to be 8 over 125. And this is going to be cubic inches. Okay. Hopefully this makes sense too, because if you just wanted to find the volume of this one of these little cubes, the volume of one little cube would just be 1/5 times 1/5 times 1/5. And if you go ahead and multiply those all together, 1 times 1 times 1 is 1, and 5 times 5 times 5 is 1/25. So the volume of this one little cube here is 1/25 cubic inches. So if you wanted to do it this way, you could do that too, because this is the volume of just one of them. And if you multiply this by 8, you can see that would be this 8 over 125 cubic inches for the volume of the entire prism. Okay. All right, let's check out number 3. For number 3, we have this right rectangular prism. The first question that we're going to answer here is what's the volume of this prism? So let's go ahead and identify the length, the width, and the height, and then get right into it. So the volume formula we can just use right away is going to be the area of the base multiplied by the height. In this case, the base is a rectangle, as all of them have been, so it's length times width times height. Let's go ahead and substitute in here. So the length is going to be 3/4. The width here is going to be 1/2, and the height here is going to be 1. I'm just going to write it as 1 over 1, even though it's a little silly. So 3 times 1 times 1 is going to be 3, and then 4 times 2 times 1 is going to be 8. So the volume is going to be 3/8 of a cubic inch here. All right, so this would be the volume of this entire prism. Now the question is for part B, it says what's the volume of one of the small cubes? So when they say one of the small cubes, they're really talking about just one of these little guys. So maybe just looking at this one little cube right here, right? So what's the dimensions of it? Well, if this is 3/4 of an inch, then there are 3 pieces here. Then one of these must be 1/4. Hopefully it makes sense if this is 1/2 of an inch, that this has to be 1/4 and 1/4. So again, if it's a cube, this must be 1/4 by 1/4 by 1/4 here, right? All the dimensions have to be 1/4. So if we're just going to go ahead, I'm just going to maybe sketch it so you can see it really clearly. Okay, just something like this. Each of these little cubes are 1/4 by 1/4 by 1/4. So it says, what's the volume of one of these little guys? Well, it's going to be length times width times height, or 1/4 by 1/4 by 1/4. And so the volume of one of these little cubes is going to be 1 over, and then 4 times 4 times 4 is going to be 64. So the volume of one little cube is going to be 1/64 of a cubic inch. That's how much space one of these little cubes takes up. Okay. The next question is how many small unit cubes are there? There's a couple ways you could really do this. Well, the amount of volume that we have total is going to be, what did we say it was earlier? It's 3/8. So let's go ahead and write this down actually. It's total volume divided by the volume of one cube. That would equal the number of cubes. This is one way we could do it. All right, so the total volume we knew was going to be 3/8, and if we want to find the number of cubes, we can divide by how much space just one of them takes up, which is 1/64. And so if we go ahead and do that, this would be what, 3/8 times 64 over 1. If you rewrite it as a multiplication problem, then you can go ahead and simplify and make this a 1 and make this an 8 here. And this would be 3 times 8 is 24 over 1, which is just 24. So there would be 24 of these little cubes that are inside of this prism. Now, you could maybe count those too if you look back at the picture, right? So if we go ahead and look at the picture here, you can see, okay, there's 3 here. So there's 3 little cubes, 3 cubes going this way. And then if you look at this dimension here, it looks like there's 2 cubes going back here. So I'm going to write 2 cubes. And then how many are going up and down here? 1, 2, 3, 4. So it looks like there's going to be 4 cubes So if you wanted to find it a different way, you could say, well, 3 by 2, there's going to be 6 cubes on the bottom here. And then how many layers of those 6 are there? Well, there's 4 layers of 6. So 6 times 4 would be 24. So the other way you could go about doing this is just saying it's going to be 3 across times 2 wide times 4 high. And so that would be another way you could say or find out that there would be 24 of these little quarter by quarter by quarter cubes inside of this prism. For part D, it says to demonstrate how we can use the volume of just one cube with the number of cubes there are to find the volume. Well, if we know the volume of one cube, so the volume of one cube, go ahead and take that and we multiply by the number of cubes. So if we know how much space one of those cubes takes up, and we multiply that by the number of cubes there are total, that should tell us the total amount of space the whole thing takes up, right? This is going to be this should equal the total volume, right? Because after all, these little cubes fill up the entire prism, right? So the volume of one cube we know is going to be 1/64th. We said that already. And how many cubes are there? Well, there are 24 of these cubes. I'm going to write 24 over 1. So if you multiply these, you're going to get 24 over 64. Now, is that the total volume? Well, if you divide top and bottom by their GCF of 8, go ahead and write that in, divide by 8 and divide by 8. Notice we're going to get a volume here of 3/8. So here we just went ahead and showed that we could still get the volume using the volume of one of these little cubes and multiplying that by how many cubes there are. And that resulted in what the volume was as well. So this is another way you could go ahead and do that and kind of link everything together. I'm actually gonna go back here and kind of box these two to hopefully make these a little bit more clear. All right, cool. Let's go ahead and see if we can try another problem. So for number 4, it says small cubes with edge lengths of 1/4 inch will be packed into this right rectangular prism below. You can see these little cubes right here, just drawn already. And it's gonna be packed into this length, width, and height into this prism. It says how many of these small cubes are needed to completely fill the right rectangular prism. Well, let's first see how many are gonna fit inside here. So for the length and the width and for the height here, how many are going to fit in? Well, let's see, for the length, if we go ahead and take the entire length, which is 4.5, and we want to see how many of these quarters fit inside of it, we can divide, right? When you divide, it tells you how many times something fits in. So 4.5 is the same thing as 9/2. And if we divide 9/2 by 1/4, that's the same thing as 9/2 times 4/1. We can go ahead and simplify the 2 and 4 right now, divide them both by 2, and we're gonna say that this is gonna be 18 little cubes that can fit across here, right? So we can say there's 18 cubes that can fit across this length here. Now, what about the width? Well, the width here is going to be 5. So the question is, how many times does the 1/4 fit into 5? And you can figure that out by doing 5 divided by 1/4 to see how many times it fits in. So this is going to be 5/1 divided by 1/4. Remember, that's the same thing as 5/1 times 4/1. That's going to be 20/1, or we can say it's going to be 20 cubes. And you should be able to fit more of these because 5 is bigger than 4.5, so we can fit 20 cubes going this way on our prism. Okay. What about the height? How many of these cubes can we stack on top of each other? Well, the height here is 3 3/4. So let's go ahead and take the 3 3/4. That's how tall this is. 3 3/4, and see how many times 1/4 fits in here. It's kind of nice they have same denominators, so this is going to be 15/4. We're going to see how many times 1/4 fits inside 15/4. This is 15/4 times 4/1. Notice these 4s are going to cancel out with each other, and we're going to end up with 15 little cubes that are going to be stacked on top of each other here. So to find the number of cubes here, let's take the 18, this 20, and this 15. Let's go ahead and take those and multiply 18 by 20 by 15 to get the total number of cubes. So 18 times 20 times 15. There should be 5,400 of these little cubes that are inside of this prism. All right, next it says, what's the volume of one of these little cubes? Well, keep in mind that one of these little cubes is a quarter by a quarter by a quarter, right? So if you want to find the volume of just one little cube, you would just say it's going to be the length times the width times the height. So 1 times 1 times 1 on top is 1, but on the bottom, 4 times 4 times 4 is going to be 64. So the volume of one of these tiny little cubes is going to be 1/64th. And what are our units here? I think these are inches, right? So it's 1/64th of a cubic inch. That's going to be the amount of space that one of these tiny little cubes takes up. For part C, it says show 2 different methods for finding the volume of the entire prism. Well, one of them is going to be taking the volume of one little cube, which is 1/64th, and multiplying by the total number of cubes that there are, which is 5,400. If you take the amount of space that one of them takes up and you have this many of them, if you multiply, you'll get out the total number of space, or the volume that all of them are together. So 1 times 5,400 is just 5,400. 64 times 1 is just 64. If we go ahead and simplify this a bit, I think 5,400, I think we can divide that by probably 8 here. 5,400 divided by 8, I believe that's going to be, let me go ahead and write what I'm using here, but if you need some more time to think about it, feel free to do so. That's going to be 675, and then 64 divided by 8 is just going to be 8. Now if you take 675, I don't think you can divide that by anything in common with the 8 besides 1, so I think this is going to be, if you go ahead and do the long division, it's going to be 84 3/8. And this would be the volume. I think the units are cubic inches, right? So this is going to be cubic inches. So this is one way you could find the volume. You just take the amount of space that one of them takes up, and if you multiply that by how many there are, that should get us the total amount of space they all take up together. Now, another way we could find the volume is just multiply the area of the base times the height, or multiply the length and width and height, because after all, this is a right rectangular prism. The length here we knew was 4.5. 4.5 is the same thing as 9/2. The width here is 5. That's the same thing as 5/1. And then the height here was 3 3/4, which is the same thing as 15/4. Okay, so the other way to do this is just multiply the length, the width, and the height. For the top here, 9 times 5 is 45. 45 times 15, surprise, surprise, is 675. And on the denominator, 2 times 1 is 2, times 4 is going to be 8. So at this point, you don't really have to do much extra work because these are the same thing. So then you can just go ahead and say, well, if those improper fractions are the same, then obviously their mixed number versions are also going to be the same. So you don't have to do any more extra work at this point. Just go ahead and say what the conclusion is going to be because we basically already have the answer. All right, so that's 2 different ways to find the volume. One way is just to use the traditional formula for right rectangular prisms. The other is find the volume of one little cube, multiply by how many little cubes there are, and that will tell you, after you simplify, the total volume of that prism. All right, cool. Let's try one more problem here. All right, number 5, we have a right rectangular prism. It has 3 different edge lengths. This time we have decimals. We have 2.5, 4, and 7.5. The prism is going to be filled up with a bunch of these little cubes that are 1/2 centimeter each. So these are going to fit in quite nicely here. So let's go ahead and just start with finding the volume of the entire right rectangular prism. So we can just do that straight up by just using the formula, the area of the base times the height. Now the base, of course, is a rectangle, so it's length times width. So we have length times width times height for this particular shape. The length is going to be 2.5. The width here is going to be 4. And the height here is going to be 7.5. So what's nice here is that 2.5 times 4 ends up just being 10. I know 25 times 4 is 100. So we have that one decimal, so just move it over, and that's just going to be 10. 10 times 7.5 is actually quite nice. We can just slide that decimal over. That's going to be 75. So the volume of this prism would be 75 cubic centimeters. That's going to be the entire volume of this prism. Okay. All right. Next, it says how many small cubes are needed to completely fill the right rectangular prism here. Well, what we can do, I guess, a couple different ways. But if we, again, have one little cube here, all right, let's just look at one little cube for a moment. It's filled up with a bunch of these. It's 1/2 centimeter by 1/2 centimeter by 1/2 centimeter. So what we can do is, actually I'll do it both ways here. One way is just see how many would fit in each dimension here. So for the length, how many times, if you have the length is 2.5, you want to know how many 0.5s fit inside of 2.5, I think you'll find out that you can fit 5 cubes going across this one. For the width here, that was 4. So if you have 4 and you want to see how many halves fit inside of 4, I believe that's going to be 8, right? 8 halves fit inside of 4 holes. And then if you take the height here, that's 7.5. So how many halves fit inside of 7.5? Well, that's going to I think be 15, because 7.5 is just 15 halves. So you can fit 15 cubes going up and down here. So if you have 5 cubes by 8 cubes, there's 40 cubes on the bottom, and then 40 cubes times 15. So if we go ahead and just find out what 5 times 8 we said is 40, 40 times 15. Go ahead and take 40 times 15 here. That should end up being 600 little cubes that are going to be going into this right rectangular prism. The other way is going to go off of C, so I'm going to do C first here. It says, what's the volume of one of these little cubes? So the volume of one little cube is just going to be length times width times height, so 0.5 times 0.5 times 0.5. Now, 5 times 5 times 5 is 125. So if you move the decimal over 3 times, it's just going to be 0.125. So the volume of one little cube here is going to be 0.125 cubic centimeters. So that's how much space one of these will take up. So going back up to part B, if you wanted to do a different way, what you could do is take the total volume, which we knew was 75, and divide by the amount of volume, or the amount of space that one of these little guys takes up. So if you take the total amount of space and you divide by the amount of space one of these little cubes takes up here, if you take 75, right? You take 75 and you go ahead and divide that and see how many times 0.125 fits inside of it, you're going to find out that that is also going to end up being 600. So that would also be 600 cubes. So that right there was the total volume. And if you divide that by the volume of just one little cube, you get the total number of cubes. For part D, it says, how can you use the volume of one little cube with the total number of cubes to figure out the volume of this entire prism? Well, we can go ahead and take the volume of one cube, volume of one cube. If we go ahead and take that information and we go ahead and multiply that by the total number of cubes, total number of cubes, this will always get us the entire volume, or the total volume of the shape. Okay, so the volume of one little cube we already found out was 125 thousandths. If we go ahead and multiply that by the total number of cubes, we said that was going to be 600 here. This is going to get us a total volume. So if you take 0.125 and you multiply that by 600, you're going to find that that's going to be 75. So this kind of just shows how you can find the volume if you just had the volume of one little cube and how many cubes there are. So there you have 5 different practice problems on kind of extending your understanding and kind of hopefully deepening it a little bit more so you can understand how to apply it a little bit differently in different contexts. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.